children, so today we'll see how to multiply matrices, multiplication of matrices. Now remember children, all matrices cannot be multiplied. Okay, so two matrices A and B are said to be compatible for product AB if and only if number of columns in A and must be equal, number of columns in A is equal to number of rows in B. This is necessary condition. All right. So number of columns in A must be equal to number of rows in B. Then only two matrices can be multiplied. Otherwise, we cannot multiply. For example, suppose you have a matrix here 1, 2, 0, 1. Okay, number of columns 2. Here 2, 1. You see, it has two columns and it has two rows. So since the number of columns in A is equal to number of rows in B, suppose this is A and this is B, okay, then number of columns in A is equal to number of rows in B, then these two matrices are compatible for multiplication. This can be multiplied. Okay, but if you see now this one, suppose you have this one. Now you see it has only one column and it has two rows. Since the number of columns and number of rows are not equal, so these two matrices cannot be multiplied. Okay, so remember, whenever you multiply two matrices, number of columns in first matrix must be equal to number of rows in second matrix. Then now what will be the order of the product matrix? So suppose matrix A has m by n order, means it has m rows and n columns, and matrix B has n by p order, meaning number of rows n, number of columns p. Then the product AB will have m rows and p columns, meaning here number of columns in A is equal to number of rows in B. Okay, and the product takes number of rows from matrix A and number of columns it takes from product B. So you have to remember. So for these two matrices to be compatible for multiplication, number of columns must be equal to number of rows, and the product will take number of rows from A and number of columns from B. Okay, so that will be clear. So we'll take example 1, question number 1, and see how we can multiply two matrices. So let's take example question number 1. Actually this question came in ICSE 2011. Okay, so given A is equal to 3, 5, 4 minus 2 and B is equal to 2. Okay, so now the question says, is the product AB possible? Okay, so here number of columns in A, so number of columns in A is equal to number of columns, how many? 2. So number of rows in B, how many rows? 2. So since these two are equal, so since number of columns is equal to number of columns in A is equal to number of rows in B, so the product AB is possible. This is the reason why the product is possible. Okay, this is the first answer. Is AB possible? Yes, AB is possible. Now if it's possible, question is find AB. Now we will multiply A and B. Okay, so find the product. So now I will use this one, second part. So to multiply, therefore this is 3, 5, 4 minus 2 and 2, 4. This is therefore AB is equal. Order is very important. Remember, AB means you must write A first and B later. If you have to find product BA, then it will be B and A. Okay, so product BA is not possible because in B there is one column, 2 rows, so it's not possible. So AB we find. Now, when you multiply two matrices, two things you have to remember. Number one, we always multiply row into column. Okay, we take row from the first matrix, column from the second matrix. So after choosing row and columns, now we multiply first element into first plus second element into second element. So this is how we multiply. Now see how we apply these two rules. So first we choose row and column. So we take first row and there is only one column. So we have taken this row into column, row into column. Now second one, so first element into first element plus second into second. So first element here into first element. So this is 3 into 2 plus, now second into second, 5 into, okay. So we multiplied by the first row, so we write in the first row. Now we multiply by the second row, so we write in the second row. So again, first into first, second into row into column, first into first, second into second. So 4 into 2 plus minus 2 into 4. You see? So two rules, remember, row into column. So row into column, first into first plus second into second here. Then by second row, first into first plus second into second. Okay. So now you simplify this, we'll have the answer. So this is 3 2s are 6. So plus 5 4s are 20. So 4 2s are 8. So plus into minus, minus 4 2s are 8. So this is equal to 6 plus 20, 26, 8 minus 8 is 0. So this is the product. Okay, answer number 1. Now, if you say this one now. Okay, this matrix A has, see, here A has order 2 by 2. 2 by 2. It has 2 rows and 2 columns. Into B has, okay, 2 rows and 1 column, that is 2 by 1. Now let's see the product. Product AB, it has, see here, it has 2 rows and 1 column. Now you see, if you look at this rule, here this number of columns equal to number of rows. Okay, so AB takes number of rows from the first and number of columns from the second, as you can see. All right. So remember this. Now let's take some more questions now to understand it better. So now let's take question number 2. This came in the year 2015. Now given A has elements 3, 7, 2, 4 and B has elements 0, 2, 5 and 3, and one more matrix C has elements 1, minus 5, minus 4 and 6. Now question says find the value of, we have to show that AB is equal to 5C. Okay, let's check this question. AB equal to 5C. Actually AB, you have to find AB minus 5C. You have to find the value of AB minus 5C. So AB minus 5C you have to evaluate, find the value of. So order is important. When it's AB, we must write A first, then B. So A is 3, 7, 2, 4 and B is 0, 2, 5, 3 and minus 5 into C is 1, minus 5, minus 4, 6. So we replace ABC by given matrices. Okay, now this is the multiplication of two matrices. This is the multiplication of matrix by a scalar quantity, which we have done before also. So here number of columns 2, number of rows also 2, so compatible for matrices. So we multiply. Now you know row into column, then first into first plus second into second. So we take first row and first column. Okay, first row and first column. So now multiply. 3 into 0, 0 plus 7 into 5, 35. Okay. Now when you multiply by first row, first column, you also write in the first row, first column. So when you multiply by first row and second column, you write in the first row, second column. So 3 2s are 6, first into first, plus 7 3s are 21. Okay. First into first plus second into second. Now here 2 into 0, 0 plus 4 5s are 20. First into first, second into second, row into column. Then second row, second column. So 2 into 2, 4 plus 4 3s are 12. Okay, first into first, second into second. Now here, it is not a matrix, scalar quantity, so you will multiply all the elements here. So 5 1s are 5, minus 5 5s are 25. Remember, minus sign is as it is, so you multiply only by 5. 5 4s are minus 20, and 5 6 are 30. Okay. So simplify further. This is 35, this is 27, this is 20, and this is 16. 4 plus 12. Minus 5, minus 25, minus 20, 30. Now subtract. Okay, so you can write equal to sign here. It's not equation, so is equal to. So 35 minus 5. So you have 35 minus 5. Then here 27 minus 25. Remember here 27 is here, this minus, then this is minus 25. So there are two negative signs here. So 20 minus again minus 20. You see 20 minus minus 20. Then 16 minus 30. Okay. So what you get, 35 minus 5 is 30. So this will be minus minus plus will become, so 5 plus 7 12 1. So it is 52. So this will become minus minus plus, so it will become 40, and 16 minus 30 will be minus 14. You subtract by the sign of the bigger number. So this is your answer, the value of AB minus 5C. Okay. Now let's take question number 3. Now question number 3, this came in the year 2000. Okay, year 2000. Given A as elements 1 1 8 3. Only A is given. So we have to evaluate, therefore A square minus 4A. Okay, so we have to evaluate A square minus 4A. So if you have to find the value A square, actually A square means A into A. So we write 1 1 8 3 into 1 1 8 3. Twice you have to write. Okay, to find A square, it is A into A. To find A cube, A into A into A. You first find A into A square, then into A again. So minus 4, A is 1 1 8 3. Okay. So don't square. So to find A square, don't square 1 1 8 3 again. This is element. So you have to write twice and multiply using the rule. So row into column, 1 into 1 is 1, 1 into 1 is 1, plus 1 into 8 is 8. Okay. Now second column, 1 into 1 is 1, plus 1 into 3 is 3. So first row finished, multiply the second row now. 8 into 1 is 8, plus 3 into 8 is 24. 8 into 1 is 8, plus 3 into 3 is 9. Okay. Now minus 4 will multiply everything. So 4 1s are 4, 4 1s are 4, 4 8s are 32, 4 3s are 12. So simplify here, 9, this is 4, this is 32, this is 17, minus 4, 4, 32, 12. Now subtract here. 9 minus 4 is 5, 4 minus 4 is 0, 32 minus 32 is 0, and 17 minus 12 is 5. So this is answer. 5005 is the answer. Okay, that's number 3. Now we take question number 4. Question number 4. This is 2010 question. 2010 came. Number 4. So we have to evaluate this one also. So it's given 4 sine 30 degree 2 cos 60 degree, then sine 90 degree and 2 cos 0 degree into 4, 5, 5. Okay. Now here this is trigonometric ratios given, so we can write the values of these ratios. So 4 into sine 30, you know, is 1 by 2. 2 into cos 60 is also 1 by 2. Sine 90 is 1. 2 into cos 0 is also 1. So this is 4, 5, 5, 4 as it is. Now if you simplify 4 into half, 2 to cancel here, so it is 2. 2 to cancel is 1. 1, 2 you get. So 4, 5, 5, 4. Okay. So now you multiply. Row into column. 2 4s are 8 plus 1 5s are 5. 2 5s are 10 plus 1 4s are 4. Then 1 4s are 4 plus 2 5s are 10. Then 1 5s are 5 plus 2 4s are 8. So this will give you 13, 14, 14 and 13. So this is the answer. Okay, that is question number 4. Now take one more example. Question number 5. This is not ICSE question. Number 5. So A is given 1, 2, 3, 4. B has elements 2, 1, 4, 2, and C has elements 5, 1, 7, 4. It has two parts. First, A into B plus C, and second part is B plus C into A. So since we have to multiply A and sum of B and C, so first find B of B plus C now. B plus C first. Okay. So B plus C, B is 2, 1, 4, 2, 4, 2, and plus C is 5, 1, 7, 4. First evaluate B plus C. Okay, B plus C, so B plus C. 2, 1, 4, 2 and 5, 1, 7, 4. So 2 plus 5 is 7, 1 plus 1 is 2, 4 plus 7 is 11, 2 plus 4 is 6. So this is B plus C. Now you take part 1. So A into B plus C. That means A is 1, 2, 3, 4 and B plus C we got here 7, 2, 11, 6. Okay, so now multiply. So this is 7, 2 11s are 22, 1 into 2 plus 2 6 are 12, 3 7s are 21 plus 44, 11 4s are 3 2s are 6 plus 24. Okay, so this is equal to 7 plus 22 is 29, 12 plus 2 is 14, see 4 plus 1 5 and 65, 4 plus 2 is 6, then this is 30. So this is A into B plus C. Now part 2. Part 2 says B plus C into A. B plus C into A. I told you order is very important. When B plus C is here, you must write B plus C first. 7, 2, 11, 6 into A is 1, 2, 3, 4. This is A. Now let's see whether these two products are same or not. 7 ones are 7 plus 2 threes are 6. 7 twos are 14 plus 2 fours are 8. Then 11 ones are 11 plus 6 threes are 18. 11 twos are 22 plus 6 4 24. So if you simplify, this is 13. So this is 22. So this is 29 and this is 46. Now see, A into B plus C is 29, 14, 65, 30, but B plus C into A 13. So remember, matrices, product of matrices may not be commutative. It can be different. Okay, answer can be different. So that's why order is very, very important. So now let's take question number 6. Now question number 6. This came in 2007. 2007. It came in 2007. Okay. So what is given is A is equal to, we are given 1, 0, 2, 1, and B is equal to, we have 2, 3, minus 1, 0, and C is equal to, we have 5, 1, 7. Okay, 3 matrices given. Okay, so this is I copied the question of 5. Number 6, A is 1, 0, 2, 1, B is 2, 3, minus 1, 0. Okay, so C is not given in this case. So now we have to find the value of A square plus AB plus B square. So A and B given, so we have to evaluate this one, A square plus AB plus B square. So how to find A square? You already know. You have to write twice, 1, 0, 2, 1 into 1, 0, 2, 1. Then AB is 1, 0, 2, 1 into B is 2, 3, minus 1, 0 plus B square is 2, 3, minus 1, 0 into 2, 3, minus 1, 0. Twice you have to write. Okay. So it's just the multiply these two matrices in this case here and then add 3 matrices again. So 1 into 1 plus 2 into 0, 0. 1 into 0, 0 plus 0 into 1 is also 0. 2 into 1, 2. 1 into 2, 2. So 2 into 0, 0 plus 1 into 1 is 1. Okay. Plus, yeah, 1 into 2, 2 plus 0 into minus 1 is 0. 1 into 3, 3 plus 0 into 0 is 0. So 2 into 2, 4. Plus 1 into minus 1 is minus 1. Then 2 3s are 6 and 1 to 0, 0. Plus here, 2 2s are 4. Plus 3 into minus 1 is minus 3. 2 3s are 6. 3 into 0, 0. Minus 1 into 2 is minus 2. Plus 0 into this is 0. Minus 1 into 3 is minus 3. 0 into 0, 0. Okay. So now simplify. This is 1. This is 0. 4, 1 plus. Here it is 2, 3, 3 and this is 6 plus. Here 1, 6 minus 2 minus 3. Okay, so add all these matrices. So you get 1 plus 2 plus 1, all 3 matrices together. Okay, then 0 plus 3 plus 6. Okay, 0 plus 3 plus 6. Corresponding elements you have to add. So 4 plus 3 minus 2. 4 plus 3 minus 2. Then 1 plus 6 plus into minus, so minus 3. So answer is 1, 2, 3, 4. So 4, 3 plus 6, 9. 4, 5, 6, 7. 7 minus 2 is 5. And 1 plus 6, 7. 7 minus 3 is 4. So this is the answer. Okay. So now we take the last question. We give you a hint. So you try. do yourself. Okay. Question number 7. This came in 2014. A is given 2, 1, 0, minus 2, and B has elements 4, 1, minus 3, minus 2, and C has elements minus 3, 2, minus 1, 4. Okay, so find therefore A square plus AC minus 5B. So A square, what to do? Write twice. 2, 1, 0, minus 2, 2, 1, 0, minus 2. Then AC 2, 1, 0, minus 2 into C is minus 3, 2, minus 1, 4, minus 5. B is 4, 1, minus 3, 2. So what you do? You multiply these two, multiply by 5 all the elements, then add, subtract, and complete. Okay. So this, I think now you know how to multiply two matrices, and you know how to add and subtract also. So you complete it yourself. Okay. Thank you.